Welcome back to another Algebra 2 video. I'm Mr. Hibble, and today we're going to be looking at graphing exponential functions. Again, we're just going to be using Desmos to do the graphing, and we're going to be analyzing the key features instead. There's one new key feature in particular that we will be talking about, but just some other stuff as reminders that we've been doing throughout the year. So first thing, let's go ahead, let's graph number 8 there. I have that graph already pulled up, and here it is. So one thing we're being asked to determine for this problem is whether it's exponential growth or exponential decay. Well, we may not know what that actually means. There's a few ways that you can find that information. One way is you could just graph it. Growth means your function is going to grow. It's going to go up. Decay means that your function's going to decrease. It's going to go down. Without any reflections or anything, this is what growth and decay functions look like. But there's also a pretty easy to tell without graphing whether your function will grow or whether it will decrease and decay. That can be done by looking at the base of your exponent. For example, b to the x is an exponential function. If you have a variable in the exponent, such as x, the input, then it makes it an exponential. The value of b could be anything. It could be something like 2 to the x or 1/2 to the x. Those values, the 2 and the 1/2, are what's known as the base of your exponent. It's the bottom of the exponent. If that base value is larger than 1, in this case, 2 is larger than 1. If it's larger than 1, that means that your function will grow. If that value, if your base is less than 1, it'll never be negative. That would make it so it's not an exponential. But if that value is less than 1 instead, that would now tell you that your function is decay. For example, this value of 1/2 is smaller than 1. Your graph would go down. What we notice on this first graph that we had here is our function is decreasing. It's going down from left to right. So that tells me it's decay right away. But the other way I could figure that out is by looking at the base of the exponent, the 2/5. 2 over 5 is less than 1. It is decay. Domain and range. Remember, domain is the left side comma the right side. How far left does your graph go? How far right does your graph go? Well, if you were to follow this graph to the left, notice your graph is going to go left forever. It's going to continue to move that way despite how fast that it goes up. Oops, wrong one. There it is. Okay, so we know that it goes to the left forever. That would mean it goes to negative infinity. And if you looked at that graph again, you would also notice the right side goes forever also. It goes left and right forever. Range is just the other directions. It's the up and down. It's the y values. It's the bottom, comma, the top. So I look at our graph again, and I want to know how far down does it go. And notice this graph does not go down forever. It goes over here to the side where it starts to level out. The graph is kind of depicted as being a straight line. So that is the furthest down this line goes. Notice the value on this left side over here. The furthest our graph goes down is that value of -6. And if we were to look at that graph, you would notice it goes up forever towards infinity. The y-intercept, you can find that easily just by clicking around. You might have to zoom out to find it. In this case, our y-intercept is way up here at 286, roughly that value at least. And an asymptote is the new information for us. So let's define it real quick. An asymptote is a line. It's a line in which your graph approaches but never crosses. A line in which a graph or a function will approach but never cross. That's the basic definition. There are some exceptions to crossing it. But as you go towards infinity, it will approach this line, is how we think about it. There's two types of asymptotes. We are going to be looking at horizontal asymptotes in this lesson. Horizontal means it goes side to side, just like the horizon. Normally, when you draw an asymptote, though, you draw it as a dashed line. We're going to draw one of those on our graph. Vertical asymptotes do occur as well. Those would be our dashed lines that you draw in where your line levels out. How I like to think about asymptotes, it's where your graph levels out. It's where it appears flat. So in our problem, we had a graph that looked like this, where it leveled out at the bottom, right? Here's that graph again if you need to see it again. But we want to know, okay, where is it actually leveling out at? Well, we said the furthest down our graph could go was -6. That's exactly what we get for our asymptote. The furthest down it gets was -6. So our asymptote is at that spot, y equals -6. Looking at end behavior, x goes to -infinity. X goes two directions, left or right. If x is going negative, it is going left. Y, where's the y going? Y goes two directions. It's either up or down. In this case, the left side of our graph is pointed up. That tells me it will go up to infinity. The other side then, this would be x going positive. That is the right side. Look at where that right arrow goes. But this one's weird. It's not going up. It's not going down. It's just going along the horizontal asymptote there. It's just kind of leveling out and approaching that line instead. So if it's not going up, it's not going down. It's just going along that line there. We just want to say that y goes to that value. It's getting infinitely closer to -6. Number 9, same idea. Let's just run through this one real quick. If you look at the value on the inside, 3 divided by 2, that's the same thing as 1.5. That would be larger than 1. It would grow. If we were to type this one into Desmos, we could answer the other parts of it. Here is that function now, this blue line here. Depicting what that looks like off to the side was something like this, where we had this asymptote down here. But let's start with the domain. The domain for exponential functions is always the same. It goes left forever, it goes right forever. Domain for exponentials is all real numbers. The range, we want to know how far down did our graph go? Well, the furthest down was that asymptote, that dashed line. That dashed line occurs where it's leveled out here. That looks like we are 2 units down, meaning it is at y equals -2. So the furthest down we got was -2. The furthest up we go, though, follow your graph to the right. It's going up, up, up. It's going up forever. Y-intercept, click on your graph, figure out where that is. Hello. There it goes. Looks like -1.8 or so. You could add the other decimals in there as well. I'm just a little lazy. The asymptote, we already defined that as being y equals -2. And now the end behavior. This is where most people make mistakes. Again, always look at what side you're being told to do. As x goes to -infinity, x goes left and right. If x is negative, that is the left side. Where is this left side going? It's not going up. It's not going down. So I cannot use the infinities. So I just need the value it's going along, which is -2. Look at the other side. X goes positive. That would mean the right side of the x-axis. The right side of your graph, the right arrow here, goes up forever and ever. So we have our infinity. There's our answer for both those two problems. This last part, I just wanted to throw it in here. It is also end behavior. The 2 here tells me this is growth. So I know my function would look something like this. If you were to graph it as well, this line here would be at y equals 4. This graph got shifted up 4 units. So what we are told on this one is create the end behavior. I got rid of the directions on here on accident, but it says create the end behavior for the left side and for the right side. End behavior has a specific setup. End behavior always starts like this, as x does something. Well, x is the left and the right direction. So if I want to talk about x going towards the left, you could picture a number line. For example, here's a number line. You have 0 in the middle, and then you have each of these values just kind of moving out towards the sides, where the positives are on one side, the negatives are on the other. Well, if you look at a number line, the values that are negative are the left side. So that tells me exactly what I should have for x. If you are talking about the left side as an end behavior, it always starts the same, as x goes to negative infinity. But now we need to answer the rest. Y goes where? There's really only one piece you need to figure out, is where is the y value going? Well, on this left side here, we see it's not going up, it's not going down, it's going along the asymptote of 4. Same idea with the right side. You need to create the statement as x goes somewhere. But I'm thinking about the right. The right is always explained the same way. It's always explained with positive infinity. Think about a number line and where the positive values are. And then we can talk about the y's and where the arrow is going. The first part of these statements tells you which arrow. The second part tells you where is that arrow pointed. We know in this case that the right arrow is pointed up. That means it is going up to infinity forever and ever. That's our 7.1, talking about some key features of exponential functions. Thanks for watching.